converted from moles to particles. So we started off with a number of moles, and then we had to convert it to the number of particles. We started here, and then we multiplied by this conversion factor and ended up with a number of particles. This time we're going to start with a number of particles and go this way. This little model shows you what the two conversion factors are for moles to particles and particles to moles. Okay, so number one, copy the problem number one in your notebook. How many moles of xenon do 5.66 times 10 to the 23rd atoms of xenon equal? And as you can recognize this number as being almost as big as the number of particles in an atom, this number here. So we're going to get a number that's somewhere close to 1. Notice in the beginning in the problem we can see that there's 3 significant figures. We have to keep that in mind when we write the final answer. So we have 3 significant figures in the final answer. Set up the equation. That's the next step. Take the only information in this sentence, this 5.66 times 10 to the 23rd atoms of xenon, and write that down, because we're going to write an equation that includes the change of units, and then we're going to get an answer in moles. So if I start off with atoms, I know I'm going to have to divide by atoms to make the atoms disappear, and I end up with moles. So I need moles over atoms. So I look up here, where do we have? Moles over atoms, or particles. So we're going to use this one, right? So we start off with 5.66 times 10 to the 23rd atoms of xenon, and I'm going to multiply that by my conversion factor. Moles, 1 mole of xenon equals 1 mole of xenon divided by the number of particles, 6.022 times 10 to the 23rd atoms of xenon. So my atoms of xenon cancel, and I just have this equation, and I take the decimal part of it and make a little problem out of it, and then I take my tenths and I make a separate problem. And I'm going to handle the tenths all by itself, because we know how to handle those. We just subtract the exponent on the bottom from the one on top, and you see that these cancel, and so it ends up being 1. So all I have to worry about is what the decimal is for this division. I take out my calculator, and I see that it comes up with 0.9398, probably some more decimals. But then I look up here, oh, three significant digits, and so I have to round this off to 0.940 moles of xenon. It's a little bit less than 1 mole, as we kind of suspected. The other problems are done the same way. The last one is half a problem, so you have to figure out what part was already done. Okay, so you can do the other 3 problems in your notebooks. Thank you.